In this video, I'll provide clear, concise and colourful solutions to Maths Paper 2 on the 2023 Ordinary Level Leaving Cert exam. This video is perfect for you if you fall into any of these categories. You've made an attempt at this paper in your own time and you want to check your answers. Your time is at a premium and you want a quick overview of the skills and procedures required to solve the questions on this paper. Or you like to study by looking at detailed written solutions. If you fall into this category, you might benefit from pausing the video from time to time and reading through the written solutions at your own pace. If you spot anything that you think might be a mistake, it would be greatly appreciated if you could let me know in the comments. I'll be sure to address it and you'll be doing a huge service for future learners who are watching this video. Question 1 AI is solved as follows. We'll label A as x1, y1 and B as x2, y2. We sub in these values into the slope formula, y2 minus y1 over x2 minus x1, and when we simplify our answer, we get out minus 2. To find the distance from A to B, we again label A as x1, y1 and B as x2, y2, but this time we sub them in to the length of a line formula, the square root of x2 minus x1 all squared plus y2 minus y1 all squared. When we sub in our values and simplify, we'll end up with a square root of 45. And if you want to present this in decimal form, you'll get 6.7082. To solve part B, we need to use the equation of a line formula. Y minus y1 equals m times x minus x1. The point we are given, minus 2, 7, gets labelled with x1, y1. The m in the formula refers to the slope, and we're told that we have a slope of 1 over 3. We can take these values and sub them in to the equation of a line formula. From here, we'll need to rearrange the equation into the given form. Ax plus by plus c is equal to 0. Notably, a, b and c should be elements of the integers z. In other words, they need to be whole numbers. To begin, we can observe that minus 2 is plus 2. Then, to get rid of the 1 over 3, we can multiply both sides by 3. Next, we multiply out the brackets on the left-hand side. And then we subtract x and subtract 2 to get everything over to the left-hand side. When we simplify this, we end up with our final answer. Minus x plus 3y minus 23 is equal to 0. A slope of 2 means that if you increase your x value by 1, then the y value will increase by 2. This means that the point 5, 4 must be on our line. Turning this the other way around, if you decrease x by 1, it will decrease y by 2. This means that the point 3, 0 is on the line. If we join these two with a ruler, we'll get the blue line I've drawn in here. A slope of minus 2 over 3 means that an increase of 3 in your x value causes a decrease of 2 in the y value. This means that 7, 0 will be on our line. On the other hand, decreasing x by 3 will increase y by 2. This means that 1, 4 will be on the line. If you join these 2 points with a ruler, you'll end up with the line I've drawn here. The equation of a circle formula is x minus h all squared plus y minus k all squared is equal to r squared. The equation we are given can be written in this form. X minus 0 all squared plus y minus 0 all squared is equal to 5 squared. H and k refer to the coordinates of the centre. Here, h is 0 and k is 0, so the centre is 0, 0. R is the radius, and here that's 5. A point will be on the circle if it satisfies the equation of the circle. In the point we're given, the x value is 3 and the y value is minus 4. If we calculate x squared plus y squared, it comes out as 25. Since x equal to 3 and y equal to minus 4 satisfies the equation of our circle, x squared plus y squared equals 25, we know that the point 3 minus 4 must be on the circle. To find the coordinates of 2 other points on the circle, a quick sketch can help. We found that the centre was 0, 0 and the radius was 5. You could sketch this by getting out your compass, putting the sharp point at 0, 0 and then measuring out a length of 5 units. From this picture, it's clear that the point 5, 0 and minus 5, 0 are on the circle. The points of intersection will be the x-y pairs which satisfy both equations simultaneously. To solve this, we'll need to use simultaneous equations. As a first step, I'll take the equation of L and rearrange it so that I've isolated y on one side. When we do this, we get 5x minus 13 is equal to y. Next, I'll take this expression and sub it in for the y in the equation of our circle. From here, we'll have to do some algebra. 5x minus 13 all squared is the same as 5x minus 13 times 5x minus 13. These brackets can be multiplied out. We can combine like terms, and then subtract 13 from both sides to get the right-hand side equal to 0. After we simplify, we're left with a quadratic equation. This can be solved using the quadratic formula. Here, we have a equal to 26, b equal to 130, and c equal to 156. We can take these values and sub them into the minus b formula. After some simplifications on our calculator, we end up with 130 plus or minus 26 over 52. To deal with the plus-minus sign, we split into 2 cases. In the first, we replace it with a plus, and we'll end up with a value of 3. In the second, we replace it with a minus, and we end up with 2. These specify the x values, but we'll still have to find the y value using the expression we found earlier. So, when x is 3, y comes out as 5 times 3 minus 13, which is 2. So this gives the point 3, 2. When x is 2, y is 5 times 2 minus 13, which is minus 3. So the point here is 2 minus 3. Camogie has 7 distinct letters. An arrangement of these letters can be thought of as follows. We have 7 empty boxes, and we need to fill in each of them with one of our letters. For the first box, nothing has been used yet, so we've all 7 letters to choose from. When we get to the second box, one letter has already been used up, so we only have 6 choices. By the third box, 2 letters have been used, so we only have 5 choices. This pattern continues. We'll have 4 choices for the fourth box, 3 choices for the fifth box, 2 choices for the sixth box, and 1 choice for the seventh box. To find the total number of arrangements, we multiply all these numbers together. 7 by 6 by 5 by 4 by 3 by 2 by 1. This gives us 5040. Part 2 is similar, but we have some restrictions. We must start with M. This means that we only have one choice to fill in the first box. It has to be M. We also need to end in a vowel. We don't have to fill in the boxes in order, so let's focus on this final box. Since there's 4 vowels, A, O, I, and E, we'll have 4 choices for how we could fill in this final box. Moving backwards, we'll have 5 choices for the sixth box. We've already used an M, and we've already used one of our vowels in the final box. When we move back to the fifth box, we've already used 3 out of our 7 letters. This means there'll be 4 choices remaining. Following a similar pattern, there'll be 3 choices for the fourth box, 2 choices for the third box, and 1 choice remaining for the second box. Again, to find the total number of arrangements, we'll multiply together all these numbers. 1 times 1 times 2 times 3 times 4 times 5 times 4. This comes out as 480. In part 3, we need to consider arrangements of 3 letters. We can think of these arrangements as having 3 empty boxes that need to be filled. When we fill in the first box, all 7 letters of the word camogie are available, so we have 7 choices. For the second box, one of the letters has already been used, so we'll have 6 choices left. For the third box, 2 letters have been used, so we'll have 5 choices remaining. To find the total arrangements, we multiply 7 by 6 by 5, which gives us 210. In plot A, the points follow a downward trend. In B and C, there's an upward trend. Negative values of a correlation coefficient correspond to downward trends. This means that the only negative value, minus 0.95, must correspond to plot A, the only plot with a downward trend. The other 2 values are 0.95 and 0.6. The larger the value of the correlation coefficient, the more strongly the points will resemble a straight line. Since the points in plot B are closer to a straight line than in C, we'll assign it the larger correlation coefficient, 0.95. By process of elimination, we can assign the 0.6 to C. In terms of an explanation for scatter plot B, we can say the following. The points have an upward trend, so the correlation is positive, and the points very strongly resemble a straight line, so the correlation is very strong, and will be a value close to 1. 0.95 was the only value provided which satisfies these properties. Rowan scores 70% of his free throws. As a decimal, this is 0.7. This form will be more convenient when it comes to doing calculations. To score his first 3 free throws, 3 things need to happen. He scores his first, and he scores his second, and he scores his third. Each of these events has a probability of 0.7. In probability, the word "and" means that we should multiply. So the answer is 0.7 times 0.7 times 0.7. This gives us 0.343. There's 3 different ways that Rowan can score exactly 2 of his first 3 free throws. He could score the first, score the second, and miss the third. Or he could score the first, miss the second, and score the third. Or he could miss the first, score the second, and score the third. On each individual shot, there's a 70% or 0.7 probability that he scores. This means that there'll be a 30% or 0.3 probability that he misses. We can use this to calculate the probability of each of our 3 scenarios. In the first case, we'll have 0.7 times 0.7 times 0.3, which comes out as 0.147. In the second case, we've 0.7 times 0.3 times 0.7. This also gives 0.147. Finally, we'll have 0.3 times 0.7 times 0.7. Again, this gives us 0.147. It's actually not a coincidence that we got the same answer each time. This is because each of our multiplications had 2 copies of 0.7 and 1 copy of 0.3. The numbers were in a different order, but this doesn't matter for multiplication. To get our final answer, we need to add together these 3 individual probabilities. 0.147 plus 0.147 plus 0.147. This gives us a final answer of 0.441. In probability, independent events are events that have absolutely no effect on each other. We need to provide a reason why scoring his free throws might not be independent. I've written the following. If he scores the first free throw, he could get in a good rhythm and become more likely to score the second free throw. This means that the result of the first free throw could affect the result of the second free throw. And this would mean that the events were not independent. To find the mean, there's 2 things we'll want to know. The total number of points Rowan has scored, and the total number of games that he has played. To find the total points scored, we should multiply together the entries in each column of our table. 0 times 4, 6 times 5, 8 times 4, 10 times 2, 12 times 3, and 16 times 1. Then, we should add together all these results. When we do this calculation, we'll see that Rowan has scored 134 total points. To find the total number of games played, we'll need to add together each value in the number of games row. We'll get 4 plus 5 plus 4 plus 2 plus 3 plus 1. This comes out as 19. So, he scored 134 points across 19 games. To find the average number of points per game, we simply need to divide these 2 numbers. 134 over 19. Rounded to 2 decimal places, this comes out as 7.05 points. The measurement of 12 centimeters that we're given can be drawn inside our circle to show that the diameter is equal to 12 centimeters. The radius can be found by dividing this number by 2. So the radius is 12 over 2, which is 6 centimeters. We have a formula which says that the area of a circle is pi r squared, where r is the radius. In our circle, the radius is 6 centimeters. We can sub this in, perform the resulting calculation, and round to 2 decimal places. This gives us our final answer of 113.10 centimeters squared. The area of a square is found by multiplying the side length by itself. Our square has a side length of 12 centimeters, so the area is 12 times 12, which is 144. The units here is centimeters squared. In part B of the question, we found that the area of the circle was 113.10 centimeters squared. To find our answer here, we need to divide these two values. Since we want an answer in percentage form, we should multiply by 100. If we perform the calculation and then round to the nearest percent, we get a final answer of 79%. In part D, we need to find the radius of the larger circle. Drawing things onto the diagram can help us here. If we join the centre of the circle to the corner of the square, this would be a radius of the larger circle. We can find this radius by considering the triangle that I've shaded in. The side on the bottom here is 6 centimeters, since it's half of a side length of the square. The side on the left is a radius of the smaller circle, and hence this is also 6 centimeters. This is a right angle triangle, so we can apply Pythagoras' theorem to find r. The hypotenuse here is r, so the theorem will tell us that r squared equals 6 squared plus 6 squared. From here, we can calculate the expression on the right-hand side, square root both sides of the equation, and then use our calculator to find the square root of 72. When we round off to 2 decimal places, we get 8.49 centimeters. This is precisely the answer we wanted to obtain. In part E, we need to find the circumference of a circle. We have a formula for this. The circumference is equal to 2 pi r, where r is the radius. In part D, we found that the radius is 8.49, so let's sub this in. After we perform the calculator work and round the answer to 2 decimal places, we'll end up with 53.34 centimeters. In a parallelogram, angles which share a side must add to 180 degrees. This means that the angle at A plus the angle at B must add to 180. It follows that the angle at A is 50 degrees. This will help us in our construction. The first step here would be to get out our ruler and measure out 8 centimeters along the given horizontal line. This gives us the point B. Then we'll put our protractor at B and measure out an angle of 130 degrees. To find C, we should go a distance of 6 centimeters along this line. The next step would be to go to A and measure out an angle of 50 degrees with our protractor. To find D, we should also measure out 6 centimeters along this line. To finish things off, all we have to do is grab our ruler and join point D to point C. In a parallelogram, opposite angles must be equal. This means that 2x minus 30 will be equal to 100. We can use this equation to solve for x. Add 30 to both sides. Perform the calculation on the right-hand side. And then divide both sides by 2. This gives us the answer that x is equal to 65. In a parallelogram, angles which share a side must add to 180 degrees. This means that 100 plus x plus 3y must come out as 180. We can use this equation to solve for y. First, we'll subtract 100 from both sides. Then we'll simplify on the right. We'll sub in the value of x we found, x is equal to 65. Subtract 65 from both sides. Simplify on the right. And finally, divide both sides by 3. This gives us y equal to 5. The statement that every square is a parallelogram is true. The justification is the following. By definition, a parallelogram is a four-sided shape where opposite angles are equal. A square is a four-sided shape. And in a square, we know that every angle is 90 degrees. This means that we do have the opposite angles being equal, and hence the shape must be a parallelogram. The gradient is defined to be the length of BC divided by the length of AC. In part I, we're given these quantities directly. The length of BC is 24 metres, and the length of AC is 135 metres. Subbing these in, we'll get 24 over 135. In decimal form, this comes out as 0.1778. We're told that the gradient should be written as a percentage. We can convert from decimal to percentage by multiplying by 100. We need to give our answer to the nearest percent, so our final answer is 18%. In the next part of the question, we're told that the length of BC is 16 metres and the gradient is 12%. We can sub these values into the formula for the gradient. Then we can rewrite the percentage as a decimal. Next, we multiply both sides by the length of AC. Then we'll divide both sides by 0.12. Performing the calculation on the right-hand side and rounding to the nearest metre gives us our final answer. The length of AC is 133 metres. We're asked to find the length of AC. We can label this unknown with x. We're told that BC is 27 metres and that AB is 105 metres. This is a right-angled triangle and the hypotenuse is 105. Pythagoras' theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Applying this tells us that 105 squared is equal to x squared plus 27 squared. We can use this equation to solve for x. To begin, we can simplify by calculating the squares. Next, we can subtract 729 from both sides. Then we can simplify on the left-hand side, and then we can square root both sides. Performing the calculation on the left and rounding to the nearest whole number gives us our final answer. X is equal to 101 meters. In the next part of the question, we need to find the size of the angle BAC. I've labelled this with theta in our diagram. In this right angle triangle, the side AB is across from the right angle, so this is the hypotenuse. The side BC is across from theta, so this is labelled as the opposite, and the final side AC gets labelled as the adjacent. We'll do something clever here to use the fact that we know the gradient is 9%. By definition, tan of theta is equal to the opposite over the adjacent. In this triangle, the opposite is BC and the adjacent is AC. This fraction, BC over AC, is precisely what the gradient was defined to be. We are told that the gradient is 9%, which as a decimal is 0.09. So, putting this all together, we know that tan of theta is equal to 0.09. To find theta, we should take tan inverse of both sides. Performing this on our calculator and rounding to the nearest degree gives us our final answer. Theta is equal to 5 degrees. The three angles in a triangle always add up to 180 degrees. This means that if you ever know two of the angles, you'll be able to find the third. We know that the angle at R is 88 degrees, and the angle at P is 87 degrees. Since the three angles must add up to 180, the leftovers remaining for the third angle is 180 minus 88 minus 87. This comes out as 5 degrees. In this question, we must find the distance from O to R. I've labelled this unknown with X. We can find this using the sine rule. To apply this, we need to find two side angle pairs, with the side being opposite the angle. Here we have a 20 meters opposite the 5 degree angle. We'll label the 20 with little a and the 5 degrees with big A. We have the side length of X opposite the angle of 87 degrees. Here we'll label the X as little b and the 87 as big B. Now that we've got our labellings, we can sub into the formula. To find X, we should multiply both sides by the sine of 87. If we perform the calculation on the left and round to the nearest metre, we end up with a final answer that X is equal to 229 metres. We are asked to find the size of the angle at X. I've labelled this unknown with theta. The cosine rule will be helpful here. This states that a squared is equal to b squared plus c squared minus 2bc times the cosine of capital A. In this statement, capital A refers to an angle and little a is the side opposite that angle. Here, we'll have capital A equal to theta and little a equal to 550. B and C refer to the other two sides of the triangle. These can be labelled in either order. Here, I'll label the 700 as B and the 800 as C. Now that we've got our labels, we can sub into our formula. Then, we can use our calculator to perform some simplifications. Next, we can simplify further by adding together two of the numbers on the right-hand side. Next, I'll subtract the 113,0000 from both sides. From here, we can perform the calculation on the left, and then divide both sides by minus 112,0000. As our final step, we can get rid of the cosine on the right-hand side by taking cosine inverse of both sides. When we perform the calculation on the left, and round off this answer to one decimal place, we get our final answer, 42.4 degrees. There's a result in the formula book which says that the volume of a cylinder is equal to pi r squared h. Here, r is the radius and h is the height. We're told that the diameter of the pool is 2.4 meters. To find the radius, we divide this by 2. So the radius is 1.2 meters. We want to fill the pool so that the depth is 0.75 meters. In this context, the height and the depth refer to the same thing. So the height is 0.75. To find our volume, we'll sub in r equal to 1.2 and h equal to 0.75. When we perform this calculation and round to two decimal places, the final answer that comes out is 3.39 meters cubed. The volume of a cube is found by cubing the side length. In this question, the cubes have a side length of 0.5. So the volume of an individual cube will be 0.5 cubed. This comes out as 0.125 meters cubed. To find the volume of 3 cubes, all we have to do is multiply this number by 3. This gives us an answer of 0.375 meters cubed. This is precisely the number we wanted to obtain. If we submerge our 3 seats in the water level will rise. The volume of the extra cylinder will be equal to the total volume that was added with the seats. We found this in the previous part to be equal to 0.375 meters cubed. The radius is still 1.2 meters. H, the height of the rise, is what we're trying to find. The formula for the volume of a cylinder is pi r squared h. We know that the volume is 0.375 and the radius is 1.2. We can sub in these values and then solve for h. To isolate the h, we should divide both sides by pi times 1.2 squared. Then we can perform the calculation on the left-hand side and round to 2 decimal places. This tells us that the amount that the water level rised, h, is equal to 0.08 meters. L appears in a right-angled triangle. To find it, we can use Pythagoras' theorem. This states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. The hypotenuse is the side opposite the right angle. In this triangle, that's L. Applying Pythagoras' theorem tells us that L squared is equal to 0.8 squared plus 1.3 squared. We can use this equation to solve for L. To begin, we can perform the calculation on the right-hand side. Then, we can square root both sides of the equation. When we calculate the square root on the right-hand side and round to 2 decimal places, we'll end up with the final answer that L is equal to 1.53 meters. This is exactly the number we wanted to obtain. The formula book tells us that the curved surface area of a cone is equal to pi RL. Here, R is the radius and L is the slant height. In our cone, the radius is 1.3 and the slant height is 1.53. We can sub these values in and then perform the resulting calculation. Rounding to 2 decimal places brings us to our final answer of 6.25 meters squared. If you cut the side of a cone and unrolled it, the radius of the resulting shape would correspond to the slant height of the original cone. This means that the radius x is equal to the slant height of 1.53 meters we found earlier. Another useful result from earlier is that the curved surface area of the cone was 6.25 meters squared. When the cone is cut and rolled out, this value will be equal to the area of the resulting sector. So in this picture, the area of the sector will be 6.25 meters squared. We'll be able to use this result to help us find the angle A. There's a result in the formula book which says that the area of a sector is equal to pi r squared times theta over 360. Here, r refers to the radius and theta refers to the angle. We know that the area of the sector is equal to 6.25. The radius is equal to x, which we noted earlier is 1.53. The angle, theta, corresponds to the A in our diagram. Putting this all together, we end up with the equation that 6.25 is equal to pi times 1.53 squared times A over 360. We can use this equation to solve for A. The first step I'll do will be to divide both sides by pi times 1.53 squared. Next, I'll multiply both sides by 360. From here, we can perform the calculation on the left-hand side and then round our answer to the nearest degree. This gives us the final answer that the angle A is 306 degrees. We must consider the number of students that have read for more than 100 minutes per day. Everyone who read between 150 to 180 minutes certainly will have read for more than 100 minutes. Similarly, everyone in the 120 to 150 class will have read more than 100 minutes. Things get a bit more tricky if we consider the 90 to 120 class. The lower bound, 90, is less than 100, but the upper bound 120 is greater than 100. So a student in here may or may not have read for more than 100 minutes. We want to maximize the number of students, so we should make the assumption that every one of these 59 students did in fact read for more than 100 minutes. To get our final answer here, we should add together 59, 18 and 10. This brings us to 87. In the next part of the question, we need to estimate the median time of the 200 students. The median can be thought of as the halfway point when all the values are listed in increasing order. In this question, we have 200 students. The halfway point would be 200 divided by 2, which would be the 100th student. The first step would be to identify which number range this student would lie in. 16 students read between 0 and 30 minutes. Since 16 is less than 100, we haven't crossed the halfway point yet. There were 35 students who read between 30 and 60 minutes. When we add these students in, we get 16 plus 35, which is 51. This is still less than 100, so after 60 minutes, we still haven't crossed the halfway point. There were 62 students who read between 60 and 90 minutes. When we add in these students, we'll get 16 plus 35 plus 62. This gives us 113, which is greater than 100. This implies that the 100th student must be inside the 60 to 90 minute range. We know that the median will occur in the 60 to 90 range. But we'll have to be a bit clever when it comes to picking the exact number we want to give as our estimate. There was a total of 51 students who read for less than 60 minutes. There were 62 students in the 60 to 90 range. This means that the 100th student would have been the 49th student out of these 62. To find our estimate for the median, we take the lower bound of the interval, 60, and add it to 49 over 62 times the length of the interval, 90 minus 60. This comes out as 83.71 minutes. In part 3, we need to explain why the method of choosing the students used could limit the validity of the conclusions. Well, the top of the question said that the students want to find out the average amount of time a student in Ireland spent reading. So they're focused on the whole country. However, they only surveyed students from their own school, so there's not a lot of geographic diversity here. The results and behaviours of students in their specific school wouldn't necessarily generalise to the whole country of Ireland. The data in the table we're given lends itself nicely to a bar chart. This is because the intervals are very regular and consistent. Each of them is exactly 30 units long. In this bar chart, I've labelled the horizontal axis with the minutes spent reading per day. This corresponds to the first row of our table. I've labelled the vertical axis with the number of students. This corresponds to the second row of our table. There were 16 students who read between 0 and 30 minutes. So between 0 and 30, we'll draw a rectangle with a height of 16. There were 35 students who read between 30 and 60 minutes. So between 30 and 60, we'll draw a rectangle with a height of 35. There were 62 students who studied between 60 and 90. So between 60 and 90, we have a rectangle with a height of 62. The other three rectangles can be drawn in a similar fashion. Between 90 and 120, we have a height of 59. Between 120 and 150, we have a height of 18. And between 150 and 180, we have a height of 10. There were 61 students with a rating of excellent out of a sample of 500. So the proportion of students with an excellent rating is 61 over 500. To write this in percentage form, we need to multiply by 100. When we do this calculation, it comes out as 12.2%. The formula for the margin of error is 1 over the square root of n. Here, n refers to the sample size. Since we had a sample of 500 students, we'll sub in 500 for n. Typing this in our calculator gives us 0.0447. Since we are asked for the answer in percentage form, we should convert this decimal to a percentage. We can do this by multiplying by 100. This brings us to 4.47%. Rounded to one decimal place, we get 4.5%. This is precisely the answer we wanted to obtain. We can solve part 3 using the following strategy. We make the assumption that the percentage of students in Cork who get an excellent rating is equal to 10%, the same as the general population. Then we'll investigate how plausible it is to get the value of 12.2% we obtained earlier. The first step is to find a 95% confidence interval. To do this, we take the 10% and then subtract and add the 4.5% margin of error. This gives us the bounds for our confidence interval. It's 5.5% up to 14.5%. The conclusion here is that the percentage of Cork students which get excellent ratings is not different from the population percentage of 10%. The reason is that the 12.2% sample percentage we found earlier falls inside the 95% confidence interval of 5.5% to 14.5%. We are told that the 5 triangles in the pentagon are isosceles. This means that 2 of the sides are equal in length. The angles opposite these sides will also be equal. In the blue triangle I've shaded in, I've labelled one of the angles as x. Since the angles opposite the equal sides are equal, the other unknown angle will also be x. We can find x by using the fact that the angles in a triangle must add up to 180. If we focus on this blue triangle, the 3 angles are x, x, and 72. So x plus 72 must be equal to 180. This equation can be used to solve for x. To begin, we can simplify x plus x into 2x. Then we'll subtract 72 from both sides. We simplify on the right hand side, and we divide both sides by 2. Performing the calculation on the right tells us that x is equal to 54. Looking back at the diagram, by symmetry, the angle I've marked in green will also be x. The angle we need to find, CBA, composes of 2 parts, the blue angle x and the green angle x. So to find our answer, we should add together these 2 angles. Well, we've already found the value of x, it's 54, so we'll get 54 plus 54, which is 108. In part B, we need to find the area of the triangle AOB. The first thing to observe is that by symmetry, the angle AOB is 72 degrees, and the side OB has a side length of 6 centimeters. From here, we can use one of the formulas for the area of a triangle which appears in the formula book. This says that the area is equal to 1/2 times A times B times sine C. Here, C is an angle, and A and B are the 2 side lengths which touch that angle. Applying that to our picture, we can let A be 6, B be 6, and C be 72 degrees. Subbing these in, we get 1/2 times 6 times 6 times sine 72. We can type this in our calculator and then round to 1 decimal place. This gives us a final answer of 17.1 centimeters squared. We also need to find the area of the pentagon, but this is straightforward. The pentagon contains 5 triangles, so its area will be 5 times the area of an individual triangle. This gives us 17.1 times 5, which comes out as 85.5 centimeters squared. As suggested in the question, a 2-way table can be used to write out the sample space. On the first spin, there's 5 possible outcomes: 1, 2, 3, 4, and 5. I've written these vertically and used them to label the rows of our table. Similarly, the second spin also has 5 options: 1, 2, 3, 4, and 5. I've written these horizontally and used them to label the columns of our table. Each box in the interior of our table contains 2 numbers. The first number, written in purple, corresponds to the first spin, and the second number, written in green, corresponds to the second spin. For example, in the top left corner, the first spin was 1 and the second spin was 1, so we wrote in 1, 1. As another example, in this box, the first spin was 3 and the second spin was 4, so we wrote in 3, 4. All the boxes in the grid can be filled out in this fashion. In part 2, we need to identify the maximum and minimum possible totals when we add together the 2 numbers that are spun. On each spin, we'll get a number between 1 and 5. The maximum total would be obtained by getting a 5 on the first spin and a 5 on the second spin. This gives a total of 5 plus 5, which is 10. On the other hand, the minimum sum would be obtained by getting a 1 on the first spin and a 1 on the second spin. So the total here would be 1 plus 1, which is 2. To find the probability of getting a total of either 4 or 5, it's useful to consider how many ways we can obtain each of these totals. Well, there's 3 ways that we could get a sum of 4 across the 2 spins. We could get 1 and then 3, 2 and then 2, or 3 and then 1. There's 4 ways we could have got a sum of 5. 1 and then 4, 2 and then 3, 3 and then 2, and 4 and then 1. Altogether, this gives us 3 plus 4, which is 7 ways to get a total of 4 or 5. If you count up the number of boxes in the table on the previous page, you'll see that there was 25 total possibilities for the 2 spins. 7 of these gave us a total of 4 or 5, so the probability is 7 over 25. In part D, we are asked to work out the expected value. This is found by multiplying together each probability with its corresponding value. Then, we add together all the results. Here, we'll have 0.3 times 1, 0.2 times 0.50, 0.4 times 0, and 0.1 times 5. These multiplications give us 0.3, 0.1, 0, and 0.5. The expected value is found by adding all of these together. This gives us an answer of 0.9. The unit here is euros, so we can think of this as 90 cents. We are asked if the game is fair, and the answer here is no. The reason is that it costs €1 to play, but on average you only win back 90 cents. Since the amount you have to pay is larger than the amount you expect to win back, the game is not fair.